Okay, 2.7 is perimeters and areas of similar figures. Remember, similar figures are made by enlarging or reducing, so dilations. So let's get started. Okay, so rule 1 here, key idea 1, is that the perimeters of similar figures, that when two figures are similar, the value of the ratio of their perimeter is equal to the value of the ratio of just one side, the corresponding side lengths. So all that's saying is if we know the ratio of this to this, which would be corresponding sides, then we know the ratio of their overall perimeter. Okay, and they're the same. So that's why they have the perimeters here set up to any of the three sides that match, but the one I underlined is the one that I have over here in yellow. So you could just set the perimeters equal to the side lengths as a proportion and then cross multiply. So if you look over here, you can see that we're going to set this up as the perimeter. The red rectangle is going to be on top, blue rectangle is going to be on bottom, and you just set it up. Well, 4 to 6 is equal to 2/3. That's just simplifying. So the value of the ratio of the perimeter is also 2/3. If we knew the perimeter of one of them, then we could find the perimeter of the other. And we'll do that in a second. Now, area is a little bit different. So area is equal to, so again, let's go back to our yellow. So the area of the two triangles can be set equal to any side. So AB and side DE are the corresponding sides squared. Okay, so we square that. The way to remember that is areas are always in units squared. Volumes would be cubed. So just we don't do that in this, but just so you know. Okay, and so as you can see down here in their example, they took the area of the red triangle and set it equal to this ratio of 6 to 10. 6 for the red triangle, blue. It's going to be important to keep these in line. So red and blue, and then they square it. Well, when you square, well, first they simplified 6 over 10 and made it 3/5 to make the squaring easier, so that was definitely smart. So they divided both these by 2 to simplify to 3/5, and then they squared it. 3 squared is 9, 5 squared is 25. Therefore, the value of the ratio of the areas is 9 over 25 in simplest form. So just like fractions, they're going to want these in simplest form. Okay, so let's do area and the area and the perimeter. Okay, so first thing we're going to do is set up the perimeter equation. Okay, so basically what it's saying is a swimming pool is similar in shape to a volleyball court. So we have our pool and we have our volleyball court. Okay, so we're going to find the perimeter and area of the pool. Okay, so they've given us the perimeter and area of the volleyball court, and we're going to use that. So the first thing I want us to do is I want us to set up, we're going to put the pool over the volleyball court on both. Okay, so for the perimeter, well, let's see. The perimeter of the pool